Okay, so we are looking at solving equations, and the first question asks if there's a mistake here. So take a minute. Do you see the mistake? So I hope that you noticed that x plus 4 squared is not just x squared plus 16. X plus 4 squared would be x plus 4 times x plus 4, which would give us x squared plus 8x plus 16. So you would have to use an area model for this. Same thing for x minus 1 squared. You would have to do x minus 1 and x minus 1, which would not give you x squared plus 1. That would give you x squared minus 2x plus 1. So that's the mistake. This is incorrect. This is incorrect. So you could just add this to your paper. Then it's asking us what values will make the following equations true. So we are going to start using some notation here when we take the square root of a number. Okay, so we're going to undo the squaring by taking the square root. So if I take the square root of 16, that is not just 4, that is plus or minus 4. So the square root of x squared is x. Square root of 16 could be positive 4 because 4 times 4 is 16. And it could be negative 4 because negative 4 times negative 4 is 16. So this is kind of the same thing over here. The square root of 16 is plus or minus 4. 4 squared is 16. Negative 4 squared, negative 4 times negative 4 is also 16, which is not the same as negative 4 squared without parentheses. That is negative 16 because order of operations we would square 4 and then we would just take the opposite of that. Okay, this is absolute value, which is the distance. Let's just write this right here. Distance from 0 to that number on the number line. So for example, absolute value of x is 4 is also going to be x equals plus or minus 4 because the distance from 0 to positive 4 on the number line is 4 and the distance from 0 to negative 4 on the number line is also 4. You can also see that on a graph. If you were to type in absolute value, which is, you would press math and then you would press the right button, and that first choice, ABS, stands for absolute value. I'm going to press X right here, and then I'm going to, so that's what the absolute value of X looks like. And if I'm looking for where the absolute value of X equals 4, I could do trace, and I'm just going to check these answers by pressing 4, enter. Okay, so the absolute value of 4 is 4, and the absolute value of negative 4 is 4. That's a way to check it. You could also go to y equals and put in the equation y equals 4. If you look at where those cross, they intersect at 4 and negative 4. Okay, over here, we're going to get x by itself by subtracting 3 from each side. So that's going to give me -3, and then we're going to write that answer as plus or minus 4. Okay, so we really have 2 answers here. We're going to do 2 little arrows, and we're going to do -3 plus 4 and -3 minus 4. -3 plus 4 is 1, -3 minus 4 is -7. So this equation has 2 solutions, 1 and -7. Okay. I was going to show you, if you wanted to see that on a graph. There's several ways that you could do that, but maybe let's just keep going. Over here we have x squared equals -16. So if I take the square root of both sides, I get x equals plus or minus. The square root of -16 is actually going to involve an imaginary number. So we will do a mini lesson on this, but really quickly, let's just write I equals square root of -1. So until now, you would have just stopped there and said, not possible. No real solutions. But moving forward, we're going to start writing the answer as an imaginary number. And the square root of -16 is the square root of 16 times the square root of -1. So I have plus or minus square root of 16 times -1. So plus or minus square root of 16 times the square root of -1 is plus or minus 4, and the square root of -1 is I. Now you may be thinking, what are you talking about? It's okay if you don't understand this today. We will talk about it more at a different time. Okay, same thing over here. If I get x by itself, I'm subtracting 4 from each side, so x squared equals -4. If I take the square root of each side, I get plus or minus square root of -4, which is going to be plus or minus square root of 4 times square root of -1, which is plus or minus 2i. Okay. These equations are quadratics, so it's asking us which ones need to be factored using area model and diamond. Well, this, I forgot to put equals 0 here. Put it equals 0. This has already been factored. So all we're going to do here is use 0 product property, and if 6x minus 18 times 3x plus 2 equals 0, either 6x minus 18 equals 0 or 3x plus 2 equals 0, and I'm just going to solve for x in both equations. So I'm going to add 18 to both sides, and that's going to give me 6x equals 18. Then I'm going to divide by 6, which is going to give me x equals 3. Here I'm going to subtract 2 from each side. So 3x equals -2. Then I'm going to divide by 3, and that's going to give me x equals -2/3. Okay, here we have a quadratic equation, so I'm going to try using the area model and the diamond, and instead of putting this on there, I'm just going to quickly sketch a little area model and diamond. A diamond is just a square turned sideways, so sometimes students have trouble, or you could just draw an X. Okay, here's your area model. So x squared and 10 in opposite corners. 10x squared in the top of my diamond, negative 7x on the bottom. So I'm looking for factors of 10 that add to negative 7. Well, 2 times 5 is 10, and if I make both of them negative, that's going to give me a negative 7. So negative 2x and negative 5x. So I'm going to find the length and the width. So this factors into x minus 5 and x minus 2. And if I'm solving for x, let's see, I'm kind of running out of room here. That's going to be x minus 5 equals 0, x minus 2 equals 0. So I'm going to add 5 to both sides and add 2 to both sides. And there's my 2 solutions. You could graph this, all of these, by the way, and look for the x-intercepts, and that would be a way to check your answer. Okay, here we have a common factor of 2. So I'm going to get rid of that common factor and divide everything by 2, which is going to give me 2 times x squared plus x minus 6 equals 0. So let's draw a little area model and diamond. So negative 6x squared on top, positive x on the bottom. So I'm looking for factors of negative 6 that add up to positive 1. So that's going to be 3x and 2x, and I'm going to make the 3 positive and the 2 negative so that when they multiply I get negative 6, and when I add I get positive 1. So that's going to factor into x, let's see, where can we write this? X minus 2 and x plus 3 equals 0. So x minus 2 equals 0, x plus 3 equals 0. Add 2 to both sides, x equals 2. Subtract 3 from both sides, so x equals negative 3. Okay, so nothing really new there. Just factoring using the area model and the diamond. Here we do have a quadratic. We're missing that bx term. So I could add that in and use area model and diamond, but I'm going to show you another way to do this. I'm going to get x by itself. The only time I can do this is if I just have an x squared term, or I just have an x term. In that case, it wouldn't be a quadratic. So I could add that 0x in here, but I'm going to just add 1 to both sides. So 4x squared equals 1, and then I'm going to divide both sides by 4. So x squared equals 1/4, and then I'm going to take the square root. So x equals plus or minus square root of 1/4 is 1/2. 1/2 times 1/2 is 1/4. I couldn't have done that if there was an x term here. I would have had to use another strategy. Could also graph it and see the answer. Okay, x squared equals 9. I'm going to take the square root of both sides. So x equals plus or minus 3. 3 times 3 is 9. Negative 3 times negative 3 is also 9. Here, I think I meant to put, I don't know what this was supposed to say. I think it's supposed to say positive plus 1. You know what, let's just skip over this one. I did a typo, and I think we can move on and just go to the next one. So here, same thing we were doing just a second ago. Take the square root of both sides. X equals plus or minus 8. 8 times 8 is 64. Negative 8 times negative 8 is also 64. Take the square root of both sides here. I get x plus 1 equals plus or minus 8. Whoops. And then I'm going to subtract 1 from each side. So that's going to give me two answers. It's going to give me negative 1 plus or minus 8, which is negative 1 plus 8 and negative 1 minus 8. Negative 1 plus 8 is 7. Negative 1 minus 8 is negative 9. Okay, here, if I'm getting x by itself, I'm going to add 64 to both sides, which is going to give me x plus 1 squared equals 64, which is the same thing I started with right here. So we don't need to keep going because we already solved it. If you wanted to check it, you could put this equation in the calculator. Okay, and I'm going to see where that equals 0. Now that is going to be not a typical window. If I hit graph, I can't really see the entire graph, which I really don't need to. But let's say you want to see this whole parabola. I want to make this window lower. I want to bring this down. So I'm going to go to Window and go to Y min and change that to negative 80. And I want to show you a couple of things. First, I'm going to check these answers. Let's see if 7 is an x-intercept. So I'm going to press trace 7, enter. Okay, that's an x-intercept. I'm going to check and see if negative 9 is an x-intercept. And then I want to show you the vertex. Now, I happen to know that this vertex is negative 1, negative 64. And I just want to point out, do you see a 1? Do you see a 64? This is called vertex form because when the equation is written like this, you can see the vertex. Now you might be saying, well, this says plus 1 and the vertex is negative 1, negative 64. I'm not going to explain all of that, but you can see what that x coordinate is. You just would need a little practice figuring out the sign. All right. Okay, we're just going to solve some equations and get the variable by itself. So here I'm solving for s. I'm trying to get s by itself. So I'm going to divide both sides. This is multiplication. The opposite of multiplication is division. So I'm dividing both sides by 4, and my answer is s equals p over 4. And that's it. So we're not going to get an actual integer for an answer. We're going to get an expression, and there will be some questions like this when you finish the Chapter 5 test. Okay, we're solving for L. So if I want to get L by itself, there's two ways I could do this, but I'm guessing most people are going to say get rid of 2w. So let's go ahead and do that. I'm going to do minus 2w. So p minus 2w equals 2l. And then I'm going to undo the multiplication, divide both sides by 2. So L equals p minus 2w over 2. Some people were dividing both of these by 2, which is fine. You could do that. You're basically factoring out the 2. So if you do that, you would have w plus L equals p over 2, and then if you subtract w from each side, you would get p over 2 minus w equals L, which is the same thing that we have over here. because if you were to separate this, this would be p over 2 minus 2w over 2, and those 2's would cancel out, and you'd be left with this. Okay, solve for x. We're trying to get x by itself. So first thing I want to do is get rid of that 3. I cannot get rid of that y first. I have to get rid of that 3, and the 3 is, x minus y is being divided by 3, so I'm going to multiply by 3 on both sides, which is going to give me 3m equals, these 3's are going to cancel out, x minus y, whoops, and I'm solving for x, so I'm going to get x by itself by adding y to both sides. So x equals 3m plus y. Okay. Solving for c, we want to get c by itself. So I'm going to get rid of 32 first. Subtract 32 from each side. So 9/5 c equals f minus 32. I'm going to get rid of 9/5. 9/5 is being multiplied by c. The opposite of multiplication is division. So I am dividing both sides by 9/5. But instead of writing this, dividing by 9/5 is the same as multiplying by the reciprocal. So you could write divide by 9/5 on both sides, but it looks a little strange. This is going to get rid of 9/5 on the right side. Now I can't just put this here without putting this in parentheses. So my final answer is 5/9 times whatever this answer was. It's not just 5/9 f minus 32. So 5/9 times whatever f minus 32 is. That has to be in parentheses. Okay. Let's put you may have learned it as copy.flop or something like that in middle school, but dividing by a fraction is the same as multiplying by the reciprocal of that fraction. Okay, solving for c, we want to get c by itself. Let's get rid of m. Divide both sides by m. We want to undo the squaring. The opposite of squaring is taking the square root. So c equals plus or minus square root of e over m. That's it. And by the way, there's one like this on the test where you're undoing the squaring. So I do have another packet if you want some more practice with this. So let's solve for r here. We're going to get rid of pi and we're going to get rid of h, and they're both being multiplied by r squared. So let's just get rid of whatever pi h is in one step. So we're dividing both sides by pi h. So r squared equals v over pi times h. Then we're just going to undo the squaring. So square root both sides. R equals plus or minus square root of v over pi times h. Okay, this is due. Turn it into either Miss Nelson or the substitute, and I'll see you soon.